So I've been having a look at different complex ions, and in this test tube here I've got some iron 3 aqueous ions, so that's FeH2O 6 times 3 plus. Now, one example of a ligand substitution reaction with a fairly dramatic colour change is this one. I'm just going to take some potassium thiocyanate and add literally a drop of that into that test tube. Give it a shake and it makes that amazing blood red coloured solution like so. So this is a ligand substitution reaction where one of the thiocyanate ligands substitutes with one of the water ligands and produces Fe H2O 5 times SCN, like so. And because that was an SCN minus, the complex ion is now a 2 plus charge, AQ, and that's produced one water ligand by that substitution reaction. Now the reason I've used that to show you is that I would now like to introduce a different ligand. This ligand is called EDTA. And EDTA is an example of a multi-dentate ligand. So EDTA, one molecule of EDTA, or one molecular ion of EDTA, has the ability to form 6 different coordinate bonds with the central metal ion. So in other words, it can form a complex with coordination number 6 with just one ligand in place. So if I take some EDTA and add it now to that blood red solution, so I've taken that colourless solution, add it to that blood red solution like so, give it a bit of a shake, and add a drop more of that like so, hopefully what you can see now is that the blood red solution has completely gone. And the colour of the solution is back closer to the Fe3 plus that it started with. And the reason for that then is that that Fe H2O 5 times with 1 SCN, which is all 2 plus AQ, reacts with one of those EDTA 4 minuses. And you can show EDTA just like that in an equation, that's absolutely fine. EDTA 4 minus AQ to form Fe EDTA. And if you remember, the Fe was 3 plus, EDTA is 4 minus, so that's an overall 1 minus charge AQ, plus the 1 SCN minus that was kicked off, AQ, and the remaining 5 waters have gone as well, liquid. Notice the number of moles of substances on each side of this equation. On the left hand side we've got 2 moles of substances, and on the right hand side we've got 1 and another 6, which is 7 moles. So by doing this ligand substitution reaction, there's an enormous increase in entropy, increase in disorder of the system. And that drives it. That's why this EDTA substance chelates, it's got the chelate effect, attaches so strongly to that central metal ion, that Fe3 plus ion. So much so that if I take a few more drops of this KSCN, remember 1 drop of it last time turned it completely blood red, I can keep adding it and adding it, and there's no sign of it going back, okay? So there's no sign of that ligand substitution reversing because that would be entropically costly. So EDTA, one example of a multi-dentate ligand, forms 6 different coordinate bonds with that central metal ion. If we use EDTA and introduce it to many complex ions, it will replace completely the ligands which are there. It will do a complete ligand substitution reaction because that generates further moles of substances here. It creates a huge increase in disorder, and that causes the delta G to become negative, and therefore the forwards reaction here is highly favourable.